So in this question, it is given that if vector A, vector B and vector C are mutually perpendicular vectors of equal magnitudes, you have to show that vector A plus vector B plus vector C is equally inclined to vector A, vector B and vector C. Now, let us try to understand what is given to us. If vector A, vector B, vector C are mutually perpendicular, mutually, like I'll be taking two of them at a time, means I can claim A is perpendicular to B, vector A is perpendicular to vector B. This is short form of writing perpendicular. Likewise, vector B is perpendicular to vector C and vector C is perpendicular to vector A. So A, B and C are mutually, means take two at a time, perpendicular vectors. So we know that if vectors they are mutually perpendicular, then their dot product is 0. So the inference that we can draw from here is vector A dot vector B can be taken as 0 easily from here. From here, the conclusion is vector B dot vector C is equal to 0. And from the third one, we can claim vector C dot vector A is equal to 0. So this information, along with these two, can be utilized at a later stage. Now, they are mutually perpendicular. What else is given? Of equal magnitudes. Next thing that is known to us is they are of equal magnitudes. That means this is modulus or magnitude of vector A is same as modulus or magnitude of vector B, same as modulus or magnitude of vector C. This is the next information that we can use or utilize at a later stage. Equal magnitudes. Now, what are they asking for in the question? What are they demanding? You have to show that vector A plus vector B plus vector C is equally inclined to A vector, B vector and C vector. Now this is sum of all the three vectors, and what they are asking for is show that this vector A plus vector B plus vector C, it results in a single vector. Now this single vector is equally inclined. Inclination stands for the angle. That means this vector A plus vector B plus vector C has equal angles with vector A, vector B and vector C. Now this is what we need to prove. That means we need to prove that vector A plus vector B plus vector C, it has equal magnitudes with vector A, vector B and vector C. It has equal inclination with all the three vectors, vector A, vector B and vector C. So let us assume that the angle between vector A plus vector B plus vector C and vector A, let us take it as alpha. Let us take the angle between vector A plus vector B plus vector C and vector B as beta. And let us take the angle which this vector A plus vector B plus vector C makes with vector C as angle gamma. It's up to you. If you wish, you can take simplified notations also. You can take capital A, capital B, capital C also. It's your choice. But if I take them as alpha, beta and gamma here. So let us recall the formula, how to write the angle between two vectors. One of the vectors is the encircled one and the other vector that we have to take here is vector A. So when we have to find angle between two vectors, it is generally obtained with the help of the cosine formula, according to which we have, if theta is the angle, then the formula goes like this: cos theta is equal to first vector, if I write it as x vector, and the second vector as y vector, then it is vector x dot vector y upon magnitude of vector x, magnitude of vector y. This is the formula for finding angle. From here, theta can be written as cos inverse of this entire expression. So, basic idea, cos theta is the dot product of the two vectors between which we are looking for finding the angles, and divided by magnitude of first, magnitude of second. So this is to be done 3 times. First time between vector A plus vector B plus vector C and vector A. Let us go for it. So we write cos of alpha is going to, it's the first vector, which is vector A plus vector B plus vector C. Its dot product with the other vector here is vector A, divided by magnitude of the first vector. The first vector here is vector A plus vector B plus vector C, and magnitude of the second vector, which is vector A over here. Now let us simplify this. Just observe, if I open it, it is A dot A plus B dot A plus C dot A upon magnitude of vector A plus vector B plus vector C and magnitude of vector A. Now observe, we have vector B dot vector A. Do we have something related to A and B? Yes. Vector B dot vector A, which is same as vector A dot vector B, this is 0. So for vector B dot vector I can write 0. Likewise, vector C dot vector A is also 0. These two terms will vanish. They will go away. Vector A dot vector A stands for magnitude of vector A whole square, and denominator is magnitude of vector A plus vector B plus vector C and magnitude of vector A. Now, single power of magnitude of A can be cancelled. So we are left with magnitude of vector A divided by magnitude of vector A plus vector B plus vector C. So this is cos alpha. Now you will observe, when we go for cos beta, it will be the angle between vector A plus vector B plus vector C and vector B. So in this case, if we wish to write cos of beta from here, steps will be similar. So cos of beta, what we will be arriving at is the way we took the dot product with vector A. So we have magnitude of vector A. Now if we take dot product between these two vectors, the numerator will be occupied by magnitude of vector B. And in the denominator, you will observe that it is vector A plus vector B plus vector C. Likewise, if we talk about angle between vector A plus vector B plus vector C and vector C, you will observe cos of gamma. And this will come out as, since here the vector being used is vector C, so it is magnitude of vector C divided by magnitude of vector A plus magnitude of vector A plus vector B plus vector C. Now just observe, in case of cos of alpha, the numerator is magnitude of vector A, denominator is magnitude of vector A plus vector B plus vector C. Denominator is same in all the 3 cases. Whether it is cos beta, you have magnitude of vector A plus vector B plus vector C. Whether it is cos of gamma, we have the same magnitude of vector A plus vector B plus vector C. So in all the 3 cases, you will observe denominators, they are identical. Something extra is also given in the question that we have not utilized till yet. We have magnitude of A, magnitude of B, magnitude of C, all 3 of them, they are equal. So magnitude of vector B is same as magnitude of vector C is same as magnitude of vector A. That means their numerators are also equal. Denominators are visibly equal, whereas the numerators, they are given to be equal. So this portion can be utilized here to claim that cos alpha is same as cos beta is equal to cos gamma. So I can write cos alpha is equal to cos beta is equal to cos gamma. So we'll be writing the direct thing from here, alpha is equal to beta is equal to gamma. So what they were asking for was to show that this vector A plus vector B plus vector C is equally inclined with A, B and C vectors. So we arrive at equal inclinations. So this is one of the most important questions from Cbse point of view. So over to question number 7.